In this video, we're going to learn how to deal with these JAMB Physics exam repeated questions under diodes in introductory electronics. So guys, we have 28 repeated questions to practice with in this video. So let's get started. The first question I have here says, which of the above are the advantages of semiconductors? We have small size, no power requirements, not easily damaged by high temperature, highly durable. So the right option to this question will be the one that has all of them, which is option B. Basically all the lists we have here are correct, so option B is the right one. I, and IV. So the next repeated question will be this one. It says, in semiconductor, the carriers of current at room temperature are, we have electrons only, holes only, electron and ions, electrons and holes. So guys, the right option to this question is option D, which is electrons and holes. Very important, guys. Take note of these particular questions. Okay, so the electrons are the negative charges, whereas the holes are the positive ones. Okay, so the next repeated question will be this one. It says, in a reversed bias PN junction, the depletion layer remains the same width, depends on the amount of reverse bias voltage applied, decreases in width, increases in width. Since it's reverse bias, so it will increase in width. The right option is option D. Next question will be this one. It says, when a pure semiconductor is heated, its resistance remains the same, increases, decreases, increases, and then increases. So guys, when it's heated, it should decrease. The right option is option C. Okay, the next question will be this one. It says, which of the following is not an ohmic conductor? We have silver, silicon, copper, metal. So the right option is silicon. Silicon here is a semi-metal, alright, a metalloid, which is not an ohmic conductor. So the right option is option B. Next question will be this one. It says, the barrier potential of a semiconductor diode is the, we have minimum voltage required to start current flow in the diode, maximum voltage that can be applied across the diode without damaging it, potential difference across the diode when it is forward bias, potential difference across the diode when it is reverse bias. So the right option will be option A, which is minimum voltage required to start current flow in the diode. Alright, so next question will be this one. It says, in a reverse bias junction diode, current flows in is by, well, option A, minority carriers, electrons only, positive holes only, majority carriers. So guys, the right option this question will be option A. So reverse bias junction diode deals with minority carriers, so the right option is option A. Next repeated question will be this one. It says, the bond between silicon and germanium is, so guys, take note of this particular question. I've often seen it repeated. The bond between them is covalent bond, option B. Next question is this one. It says, pure silicon can be converted to a p-type by adding a controlled amount of rare pentavalent atoms, tetravalent atoms, trivalent atoms, hexavalent atoms. The right option here is option C, which is trivalent atoms. Very important. Next question is this one. It says, which are the charge carriers in semiconductors? We have ion and electrons, ion and holes, holes only, electrons and holes. The right option is option D, which is electrons and holes. Okay, the electrons being the negative aspect, the holes being the positive aspect of the charge carrier. So next question will be this one. It says, a semiconductor diode is used in rectifying alternating current into direct current mainly because it offers high input resistance, is nonlinear, allows current to flow in either direction, allows current to flow only in one direction. So the right option is option D, which is allows current to flow only in one direction. Next question will be this one. It says, the battery connection that permits current to flow across a PN junction is called, we have option A, rectification, amplification, reverse bias, forward bias. So the right option here is option D, which is forward bias. Take note of this question as well. Next question will be this one. It says, when a semiconductor diode is forward biased, what happens to the resistance of the diode. The resistance can either increase or decrease depending on the doping level of the diode. The resistance remains constant, the resistance increases, the resistance decreases. So it's talking about forward bias. So basically guys, the resistance will decrease since it's talking about forward bias. Okay, so take note of this particular question as well guys, very important. Next repeated question will be this one. So it says, which of the following is a pure semiconductor? We have carbon, phosphorus, silicon, transistor. So this is simple question, is silicon. Option C. The next repeated question will be this one. So guys, before we attempt this question, if you are new to the channel, ensure that you are subscribed to this channel for more of our videos. Really appreciate this. So this question says, signal diode is used for, we have voltage regulation, power amplification, energy conversion, current amplification. So the right option is option A, which is voltage regulation. Next question will be this one. It says, a PN junction diode can act as rectifiers because they conduct current when reverse bias, conduct current in both directions, conduct current when forward bias, block current when forward bias. So the right option to this question will be option C, which is conduct current when forward bias. So option C, the right option. Next repeated question will be this one. It says the current in a reverse bias junction is due to, we have holes, majority carriers, minority carriers, electrons. So since it's reverse bias is due to minority carriers, the next question will be this one. It says a diode is not used for option A, amplification, regulation, detection, instrument protection. So the right option is option A, which is amplification. The diode is not used for amplification. The next question will be this one. It says the bond between silicon and germanium is, I think we've answered this question already. The right option is option C, which is covalent. Okay, the next repeated question will be this one. It says in a reverse bias voltage, it says if a reverse bias voltage is applied across a PN junction, the depletion layer width is half, increase, constant, decrease. So since it's talking about reverse bias, so basically the depletion layer width will increase. Okay, option B is the right option. The next question will be this one. It says ripple in a power supply unit is caused by, we have heavy load using a Zener diode, forward voltage load using an alternating current source. The right option is option D, which is using an alternating current source. The next question will be this one. It says which of the following is a semiconducting material? So the right option is option A, which is silicon. The next question will be this one. Which of the following statements is true about the conduction and valence bonds of a semiconductor? We have option A, the conduction band is always full while the valence band is always empty. The conduction band and the valence band can overlap. The conduction band is always empty while the valence band is always full. The conduction band and the valence band are always separated by a finite energy gap. So the right option here is option D. Alright, very important. The next question will be this one. It says a PN junction connected in a reverse bias arrangement is characterized by high conductivity, medium resistance, low resistance, high resistance. So guys, the right option here is option D, which is high resistance. Alright, the next repeated question will be this one. It says which of the following statements correctly describes the relationship between resistance and temperature in a semiconductor? We have the resistance of a semiconductor decreases as the temperature increases. The resistance of a semiconductor decreases exponentially as the temperature increases. The resistance of a semiconductor is independent of temperature. The resistance of a semiconductor increases as temperature increases. So the right option is option A, which is the resistance of a semiconductor decreases as the temperature increases. Next repeated question will be this one. It says in a semiconductor junction diode, as the depletion or barrier layer is forward bias, the layer basically we have remains constant, it widens, then narrows. The right option is option D, which is narrows. Very important. Next question will be this one. It says a PN junction diode is used as, we have an amplifier in a DC circuit, an amplifier in an AC circuit, a rectifier in a DC circuit, a rectifier in an AC circuit. So the right option is option D. Take note of this question: a rectifier in an AC circuit. The last question before we end this video with this one, it says the bond that forms a semiconductor is, so option B, the right equivalent. So guys, this is basically how you can deal with problems involving diodes in introductory electronics for the JAMB Physics. We practice with 28 repeated questions for this topic. Hope you learned something interesting from the video. Let's go to the video, guys. If you are new to the channel once more, ensure that you subscribe to this channel by hitting the subscribe button for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave a question in the comment section below, and I'll ensure to keep your response. Also ensure that you're part of the channel membership by clicking the join button, where you'll be receiving special information that will help to simplify your academic work. So having known that, click on the screen above and I will see you in the next video. Thanks for watching.